Welcome back to lesson 26. We are going to talk about trinomial factoring. Trinomial factoring is basically undoing a binomial distribution. So instead of multiplying, we're going to be dividing and looking at factorization and factors. We just did monomial factoring, and monomial factoring is where we had 4x squared plus 6xy, and we pulled out a common factor, which in this case would have been 2x times 2x plus 3y. See how that works? We did the reverse. Instead of doing the distribution, we grouped. We factored. That's what we did. So we're going to be doing the same thing, but we're going to be doing it with trinomials. And one of the key factors, or the key things that you have to do in order to factor trinomials, is that your expression has to be written in degree order. So when we're given a problem that looks like this, we have to reorder it. We have to put it in order of the degree of the variable. So x squared goes first, minus 5x because the sign stays with the term, plus 6. So now we're going to set up our two binomials. Just put in our parentheses like that. And then we're going to think about this first term. What times what gives us x squared? X times x. Right? Now we have to think about the factors of 6 that when multiplied together would give us a negative 5. All right, in order to get a positive 6, our only options are we could do positive 6 times positive 1. We could do negative 6 times a negative 1. We could do a negative 2 times a negative 3, or a positive 2 times positive 3. All right, if we combine these two, we get a 7. Combine these two, we get negative 7. If we combine these two, we get negative 5, and we combine these two, we get a positive 5. So this is the one that we want. So we take the factors of negative 2 and negative 3 and drop them in. And because this x is the same in both, it doesn't matter which side you drop it in. So you could put negative 3 here, or you could put negative 2 here. It doesn't matter. It works the same way. All right, and the way you make sure that you have factored it correctly is just to check it. So x times x gives us x squared. X times negative 3 gives us negative 3x. Negative 2 times x gives us a negative 2x. And negative 2 times negative 3 gives us a positive 6. And when we combine like terms, we get x squared minus 5x plus 6. And that is the same thing that we had up here, so we know that this is factored correctly. All right, let's do 25.2. Just to submit this practice. We have negative x squared plus 5x plus 14. Sorry, it's not a minus. All right, now what is the one thing we don't want to have to deal with when we factor trinomials? We don't want to deal with a negative variable. Those things stink, so we're going to get rid of that by factoring out a negative 1. Now when we factor out a negative 1, it changes all the signs here. So this becomes a positive x squared, this is a negative 5x, and this becomes a negative 14. Now we can set up our binomial here. So negative 1, and then we'll have one set of parentheses and another set of parentheses. Now we know that x times x is x squared, so we drop that in. And now we need to look at negative 14. What factors of negative 14 give us negative 5? So we could say negative 2, positive 7, that gives us a positive 5. We could say negative 7, positive 2, that gives us a -5. That's what we're looking for, so that's what we'll use. And because these are the same, we can drop them in any order as long as we keep the correct sign with them. So now we check it. We say x times x is x squared. X times +2 is +2x. -7 times x is -7x. And -7 times +2 is -14. Okay, and we combine like terms. We have x squared minus 5x minus 14, and we can't forget our -1. So when we say -1 times all of these, it changes the sign. And that's the same thing that we started with, so we know that this is the correct factorization of this trinomial. All right, pause if you need to and take notes. And let's see, how many more do we have? We have 2 more. So I'm going to write them up here, and then I'm going to let you work. I'm going to let you work both of them. All right, here are the 2 problems, these 2 expressions to factor. So I want you to write those down and to factor them out, and pause the video, and then come back and we'll work through both of them. All right, so I am assuming that you took the time to work both of these out. And if you got for 26.3, -3 times x plus 4 times x minus 2, then you got the correct answer. And if we were to do the distribution on that to check it, we would see x times x is x squared. That's -2x, +4x, and -8x. And you know what? I got the wrong answer. You know why? Because it's going to end up being a +2, and that's not what we want. So what I should have done, see, that's why you check your answer, boys and girls. This should be negative, and this should be positive. So now it's the correct answer. Always check your work. So when we check our work this time, we get -3, and it's going to be times x squared minus 4x plus 2x minus 8. When we combine, we get -3 times x squared minus 2x minus 8. And when we distribute the -3, we get -3x squared plus 6x plus 24, which is our original up here. So we know that this is the correct answer. But you have to check your answer to make sure that you have the correct positive and negative signs. See, everybody's human. We all make mistakes. But we can learn from our mistakes and do them over. Sometimes, not every time, but a lot of times we can resolve it if we learn from our mistakes. So, especially in math. 26.4. Let's see if I got this one right. I might have gotten it wrong too, because I did not check my work. Okay, so let's check this one. Let's see if I got it right. I think I got it right. -2x squared times x minus 8 times x plus 2. Okay, so if we do -2x times x times x is x squared, right? X times +2 is +2x. All right, now for the second number, -x times or negative 8 times x is negative 8x. And then negative 8 times positive 2 is negative 16. All right, so that's going to be negative 2x times x squared minus 6x minus 16. And when I multiply negative 2 times all of these, I get negative 2, oh, I'm sorry, that should have been a square here and a square here, x to the 4th plus 12x to the 3rd plus 32x squared. And that's the same thing that we started with here and here. So that tells me that I got this one correct. Awesome. All right, so if you got these two answers correct, then good job. Good remembering. Very proud of that. And if you did not get those correct, then you need to pause the video and look back at how this problem was worked and correct your notes so that you get it right next time. Okay? Once you're done with that, let's move on. I'm going to clear the page. And we're going to talk about overlapping right triangles. I know, we keep talking about triangles and overlapping and scale factors. I think it's because the book really wants you to learn it really, like a lot. So we're going to look at it from a different angle this time. We have a right triangle, hopefully. Okay, that's really a sad right triangle. Let me make it more of a right triangle. There we go. And let me level this out. There we go. Now we have a right triangle. I'm so proud. And of course, he's divided. So let's draw a straight line here. And this line is parallel to this line. So that means that this is also a right triangle. So guess what? We know for a fact that this angle on this large triangle is the same as this angle on the small triangle. And because they're both right triangles, we know that this one is the same as this one, which tells us that, of course, this one is congruent to this one, right? Easy peasy. So now they're going to give us some dimensions. This is 4. This is 6. This is 4. This is A. And this is B. And this is C. What? We don't have that third on the small triangle. And we don't have anything on this side at all. How are we going to do this? Okay, let's put on our thinking caps. Let me drag this over here so we have some room. And let's think about it for just a minute. So if we have a right triangle and this is the hypotenuse, we know how to find this measurement because we know the Pythagorean theorem. So all we have to do is figure out what A is, right? And then we can get a scale factor, right? Okay, so let's look at it. We know that 4 squared plus 6 squared is going to equal, this is A squared, right? So this is 16 plus 36 is equal to A squared. All right, 16 plus 36 is 52 is equal to A squared. So that means when we get the square root of both of these, the square root of 52 is equal to A. So A is the square root of 52. Awesome. All right, so now we have a dimension for all three sides. It might not be pretty, and it might not be a number that we like, but it is still an accurate number. It is the exact value in the format that it is in. So we're going to use it that way. So again, we have the bigger triangle and the smaller triangle, and I'm going to separate them because it is so much easier to see when we can split them up. So I'm going to copy this and I'm going to paste it down here, right? And I'm going to remove everything from the bigger triangle off of this one. And everything from the smaller triangle off of this one. And all that means is I have to take off this one little line and this little dimension right here. Now you can see it a little bit better. We know that this side is going to be a plus b. And this side is going to be 6 plus 4. Right? So that means that this side equals 10. So we have a scale factor now. We know that 6 has a scale factor that takes it to 10, so we can figure that out. So 6 times some scale factor takes us up to 10. So our scale factor is going to be 10 over 6, which reduces to 5 over 3. Right? So now we can find out what C is pretty readily. Because, yeah, I took the 4 off of here. Sorry. I knew I was missing something. So now we can look at this 4 here, and we can multiply it times our scale factor and find C. So let's do that first. So 4 times our scale factor of 5 over 3 equals C. So that's going to be 20 over 3. So we know that 20 divided by 3, that's 18. That's 6 and 2/3. Right? So this is going to equal 6 and 2/3. Right, so we found C. We know what this is. Quite technically, we could take this and square it and this and square it, and then we would find the answer to what A plus B is, right? We could easily do that. But let's just use our scale factor here of A to find B. So we know that B, let's erase this. We know that B is the square root of 52, or we know that this side is the square root of 52 plus B, right? So, and that this is just the square root of 52, right? So let's use our scale factor to figure that out. So we're going to say the square root of 52 times our scale factor, which is 5 over 3, is equal to the square root of 52 plus B. Okay, do you see how that works? All right, we know if we scale this up that it should be the same as this. So now let's do our multiplication. So we have a fraction here. Let's multiply both sides by 3 so we can get rid of this fraction. So if we take this and multiply it by 3, and we take this and we multiply it by 3, let's distribute 52 times 5 divided by 3. The 3's will cancel. So we have 5 times the square root of 52 left, right? Equals 3 times the square root of 52 plus 3 times B. Okay, if we bring this over here, we're going to get -3 times the square root of 52. So we're going to have a remainder of 2 times the square root of 52 equals 3b. Right? So if we divide both sides by 3, first, let's see if we can simplify this. I think that would be easier. So let's look at our factor tree for 52. All right, 52 is equal to 2 times 26, and 26 is 2 times 13. That's as far as we can go. So we can pull a pair of 2's out. So, all right, let me write this in a way that's much more accurate. Square root of 52 is equal to the square root of 2 times the square root of 2 times the square root of 13. So when you have the square root of 2 times the square root of 2, you get 2 times the square root of 13. So we've pulled 2 out. We already had a 2 times this. Now this becomes 2 times 2 times the square root of 13. So that's 4 times the square root of 13, right? And that is equal to 3b. Now that this is completely simplified, we just divide both sides by 3, and that's going to be 4 times the square root of 13 divided by 3 equals b. That's as far as we can go. That is all that we can do for b. So the length of this side here is the square root of 52 plus 4 times the square root of 13 over 3. That's all we can do. That is our answer. And it is an accurate answer, and we're done. That's it. So sometimes you don't get the answers that are pretty, that come out just right. That's okay. Math doesn't ever promise that the answer will be pretty. It just promises that logically it'll be correct. And this is where we ended up. So this is all we have for lesson 26. I'll see you in lesson 27.